Hi, how's it going? We are wrapping up Chapter 7 today. This is 7.5, and we have some special proportions in triangles, and that's what we're going to look at today. One of them we call the side splitter theorem, which I think is kind of a silly name, but, you know, I didn't write the textbook. Side splitter means you're going to have this triangle, and when you put in a parallel line to the base, and this parallel line can go anywhere. We've dealt with like the mid segment. This doesn't even have to be just the mid segment. It's anywhere as long as it's parallel. It splits the sides into a proportion. So it says that, okay, if these are parallel, then let's look at this proportion. It says XR to RQ would equal YS to SQ. All right, that makes sense. It's just, breaks it up so that it looks, the parts are proportional. So the little to the big, little to the big. All right, so if you look at this one, let's try that. And we're going to set this up, so we're going to go, these are parallel, so little to big equals little to big. So x plus 1 to 12 equals x to 9. All right, and then we just do our cross products. So here this is a little bit different because we're going to have to distribute that 9, so that's going to be 9x plus 9 and equals 12x. Let's move the 9x to the other side by subtracting it. Divide by 3, and we've got it, x is equal to 3. All right, that's the side splitter theorem. All right, see if you can do this one. Again, it's got some variables in there that make it a little bit trickier. See if you can go find A. All right, here's what I got. And I do want to mention there that, remember what we've learned in this chapter is that there are certainly different ways to set up valid proportions as long as we end up with the same cross products. So you might have set this up a little bit differently, but as long as you got an 18 times an A and a 12 times an A plus 4, then your proportion is okay. So now this is a corollary to the side splitter theorem, and it's really just means that, okay, you don't have to this doesn't just work in a triangle. If you just have a bunch of parallel lines, like I've shown here, you can just have these transversals cutting through here. It's still going to, these parallel lines are going to break these transversals up into proportional parts. And the way they have it set up is they've got AB to BC was WX to XY. So you're just pulling out the parts of the sides and saying that they are proportional. All right, and then here's our last theorem about proportions in triangles, and this one's different. You can see there's no parallel line going on. What you have instead is an angle bisector. We call it the Triangle-Angle-Bisector theorem. You take your triangle and you drop an angle bisector in there. So these two angles are going to be congruent. Okay, now what ends up happening with an angle bisector is it splits, and you can see the proportion here, it's going to split this triangle into proportional parts. So what it does is it says, okay, well then where this comes down and hits, it breaks this up, and we have CD to DB, so the two parts of that opposite side have the same ratio of AC to AB, the two sides. And you got to keep it in the same order. So I'm going from this to this equals side to side. Okay. All right, you can see here that you've got the angle bisector, and so it's going to split the side here into parts that are proportional to the legs. All right, I'm going to set this up. I'm going to say, all right, well, 10 to 18, let's go that route, equals, and then I got to go back into the right order, so I got to go to the same side. Since I went to the left, I went to the 10, then I'm going to go to the 12 to x. Now cross products. 10x equals 12 times 18 is 216. Divide by 10. So x is 21.6. All right, you try the angle bisector theorem. See if you can set this up and solve for y. Go ahead and pause the video. Come back when you're done. right, here's what I got. Again, as long as you have the same cross products as I have, you're okay. You might have gone to the other side first. That's okay. All right. That's all we have for today. So it's a pretty short little lesson. There'll be some review problems on your homework also to kind of help start getting us ready for our test. Good luck.